Hello, welcome to a new video where we will talk about implementing multi-agent solutions for electrical transformer maintenance and how this can optimize both operation and equipment care.
I am very interested in learning much more about the subject. In the previous videos, I have learned a lot, especially how this approach could help us to improve our management and prevent possible problems in the future.
Right, let's start with the basics. Transformer maintenance begins with preliminary audits and analysis. These activities are key to assessing the current condition of the equipment, identifying potential risks, and planning interventions. For example, visual inspections, inventory of the history of all overhauls performed in previous years, and tests such as dielectric oil analysis help us detect contaminants, leaks, or other problems.
And what is the main benefit of these audits?
The main benefit is the prevention of failures before they cause serious interruptions. For this purpose, it is very important to know the transformer's history in order to have the background. By knowing the history, it is possible to have a better traceability of the transformer. A practical example is to use thermography to detect hot spots that could lead to a breakdown. If we have the thermography previously performed, we could analyze the evolution of that hot spot. This not only guarantees service continuity, but also optimizes resources by prioritizing maintenance according to criticality.
Got it. Now, what role do the intelligent agents you mentioned at the beginning play?
Excellent question. Intelligent agents are specialized systems that store data, monitor, diagnose, and act autonomously. Depending on their design, they can be simple agents, ideal for repetitive tasks, or goal-based, which optimize their actions towards specific goals, such as extending equipment life.
Can you give me an example?
Of course. Imagine an agent that continuously monitors the condition of the transformer and prioritizes interventions according to the impact on the network or production. This agent could detect abnormal levels of dissolved gases in the oil, predict a failure, and recommend immediate action.
Sounds very useful. But how do you ensure the effectiveness of these systems before implementing them?
That's what controlled environment testing and simulations are for. These allow us to model real scenarios and analyze the behavior of the agents without risk to the equipment. For example, using digital twins, we create a virtual replica of the transformer that reflects its condition in real time. In this way, we anticipate potential failures and optimize maintenance strategies.
It is clear to me. Now, if we think about a real implementation, what would be the process?
We are talking about a gradual deployment. This involves starting with a pilot, where one or several transformers are monitored to adjust strategies and ensure that everything works as expected. We then expand the scope and synchronize the new equipment with the existing network. The key is to adjust the plan based on the data obtained.
And how do you manage the expansion of an entire power system?
Expansion should be planned, considering energy demand and complying with regulations. For example, before installing new transformers, the location can be evaluated to minimize losses. In addition, technologies such as real-time sensors and predictive analytics can be integrated to keep the system operating efficiently.
That also includes ongoing maintenance, right?
Exactly. It is essential to combine preventive maintenance, such as scheduled or regulatory inspections, with predictive maintenance, which analyzes data in real time. This ensures that equipment is always in its best condition. For example, every test and repair can be recorded to adjust future strategies.
This all sounds very promising. What are the long-term benefits?
In the long term, you ensure the reliability of the power supply, reduce costs by avoiding unexpected failures, and extend the service life of transformers. Plus, you adapt to growing energy demands with a robust, well-managed system.
I am convinced. What would be the next step to implement this?
The first step is to perform an initial diagnosis with preliminary audits and analysis. Then, a tailor-made plan can be designed with an initial pilot to test different solutions and expand gradually. We will be with you every step of the way to ensure success.
Perfect. How can I move forward? Thank you very much for the information.
Thanks to you for this talk. Just contact our expert Antonio Fresco Navacarata via LinkedIn. He will be able to guide you in the next steps.